Thank you very much for the invitation to be here today. I'd like to thank Rudy and the other organizers for this meeting. This is the first time I've attended this meeting. It's been a wonderful visit. I've got to connect with friends and colleagues and meet new people, so I look forward to the next couple days. Today I'm going to be talking about invasive species. I should caveat this. About a good 50% of my research focuses on looking at the impacts and management of invasive species. I came into this field, much like many of us that do study invasive species, with this preconceived notion that invasive is bad and that we should try to prevent these harmful organisms from causing ecological havoc. I continue to have that perspective, but today I'm going to be talking a little bit about the role of scientists and how we shape the public perception of invasive species, how our past efforts might have hindered our ability to translate science into on-the-ground management, and then some scenarios about where the future might be with respect to these organisms. I always like to start with this photo because it depicts the challenge of what we have to do. This is a woman in the Sydney airport who got arrested for smuggling in 51 different species of aquatic organisms. That's pretty amazing. It highlights the fact that predicting species invasions is chronically difficult. Sir Robert May once said it was as difficult as predicting earthquakes. I would tend to agree in some instances. So this just illustrates some of those challenges. Let me start by the doom and gloom. Invasive species are stand accused of ecological damage, mass murder, horrific crimes on nature, alien, non-native, invasive, exotic, whatever you want to call them. They're among us, and we are particularly interested in looking at their ecological harms. In fact, although we know only a small fraction of non-native species cause ecological harm, those that do can be quite large. This was a recent review paper that I was a co-author on along with Julian, looking at the impacts of non-native fish. I just illustrate this to show that we know that these impacts occur at different levels of ecological organization. They involve a number of different mechanisms. And there's been similar review papers, obviously, before this one that illustrates the challenge ahead. And what is this challenge ahead? The discipline of invasion biology has been really a growth discipline. It's really been a great place to invest a lot of work. We've seen emerging journals like Biological Invasions, Aquatic Invasions, Neobiota recently started up last year. So there's a lot of effort that's gone into invasion biology. Some people actually say it's a discipline or a subdiscipline of ecology. In fact, it is just a form of ecology. But what's really interesting is that although research has really accumulated over the past 5 decades, much of this information has not really gotten into the management or policy arenas. And one might ask, why is this the case? Well, at its core, policymaking really involves this struggle over ideas and perceptions. And as scientists, it's our role to actually shape the science and do the science that ultimately leads and provides information so that policymakers can actually generate their own ideas and perceptions of invasive species. Why is this such a challenge? Well, unfortunately, the public perception of invasive species is highly dynamic and very difficult to understand. We can go to North America, for example, and look at the history of the environmental movement or environmental history of the US, and we can see that in the 19th century, invasive species were looked at very favorably. We are intentionally moving organisms to give us a sense of place about where we came from. This was recreational opportunities, for example, for fishing. And then post-World War II, we saw a really reversal in terms of our attitudes of non-native species. They're hitchhiking in a multiple of different pathways and vectors. They started causing ecological harm, and now they're viewed in a more negative light. But really, it's highly dynamic about who you ask, whether or not, say, bass or rainbow trout is viewed positively or negative, i.e. is a non-native species or an invasive species. So policy decisions and management actions occur within this complex web of ideas and perceptions. I would argue that as scientists, we have to play a more active role in terms of shaping this debate. And how have we shaped this debate thus far? I would argue that, unfortunately, we've done not the best job in terms of the language in which we have used to describe non-native or invasive species. And I put up this figure here, which is the invasion of the Asian carp into the United States. Many of you have probably seen the YouTube videos in which they come flying out of the water and hit innocent people in the head. Or in the States, we like to make a sport of everything. There's now extreme aerial bow fishing, in which for a mere couple $100s, you can sit on the back of this boat with a bow and shoot the carp as they come out of the water. But what's interesting in the science, this is from last year, and this is a quote from Science magazine. And in the very first sentence, you can see the type of terminology that we use with invasive species in terms of scrambling to shore up our defenses against these non-native organisms. In fact, the language which routinely pops up in the literature includes battle, harm, or destroy, or the meltdown of invasive species. We need to prevent them, restrict them, stop them. And the use of these war metaphors are actually good in many instances. We can think back in the 1930s, British Medical Society came up against the war against cancer. That's still a term that we use routinely when we're talking about cancer. But I would argue that, unfortunately, it sometimes provides a very kind of one-directional view on non-native species. Unfortunately, emotions can run high when we talk about invasives. I've been to many different conferences in which scientists have called them evil, that we must destroy them. And I would say that that xenophobic kind of terminology is actually quite counterproductive when we're trying to translate our knowledge of invasive species to the public so that they can form their own perceptions about this problem. I would argue that the choice of words are just as important as the choice of the science in which we do. And rather than using the terms prevent, restrict, or stop invasive species, I think we shouldn't direct against the negative, but actually put our efforts towards creating the good. And I really think this really contributes not only to invasive biology, but also to conservation biology, which we like to talk about the gloom and doom of what's going on, as opposed to trying to focus on a future, a brighter future, in which we can create through our own actions. I always use this example in the United States. We can think back at the steps of the Lincoln Memorial in 1963. Martin Luther King went up there and gave a speech, "I have a dream." Imagine what would happen if he started that speech with, "I have a nightmare." A very different direction might have occurred. Again, we should be focusing on creating the good rather than restricting the bad. Well, doing this, and I guess I just want to illustrate that this kind of permeates into the scientific literature. This is a recent article by Mark Davis and a number of 18 other eminent ecologists who make the general argument that the notion between native and non-native might become less relevant when we look into the future. I highly disagree with this perspective. I think there's high utility in differentiating between native and non-native, but they do make some good, important points that myself and others have made recently in the literature, in which non-native species do have conservation value in many places, and we need to recognize that while we're talking about this conservation challenge ahead. And I just illustrate this again, that you can call me a reformed xenophobic, if you will. This is the snakehead shown here. This is a really bad horror movie. They feed on your fear, Snakehead Terror. So anyways, I just put this to say the fact that we need to have a more balanced treatment in terms of our investigation of non-native species so that we have scientific credibility and greater scientific rigor in our own studies. So one of the problems that we have is that many who oppose non-native species recognize, unfortunately, only the few non-natives that actually have ecological damage, and they are taught to dislike them at the onset, as opposed to having a deeper knowledge of the species around them. And I'd say this is a critical challenge for us. The truth is when we look to the future, it's going to be a mix of both new and old species. We call, a number of things have called this. Michael Soule called this the mixology of the future. These are emerging ecosystems, novel communities, whatever you call it. And we need to talk about not necessarily controlling it, but really what we should use in terms of producing a more bright future. Well, going from the probable to the possible involves a number of things. Species invasions are contingent on a number of factors, exceedingly difficult to predict. And unfortunately, prediction means very different things to different people. Scientists know that prediction as kind of a conditional statement about the likelihood of something occurring, whereas the public looks at it as something is going to happen regardless about what they do currently. It's a weather prediction or a weather forecast. They can't control it. It's going to happen. So this is where I think scenario-based projections provide some means of really articulating this highly uncertain, unpredictable science into something tractable that the public can then grab onto and understand in terms of shaping their perceptions of non-native species. So a projection is some kind of indication of a possibility, and normally something that can be influenced by personal or political actions, and I think that engages the public more so. So if we look at this graph here, Gary Peterson did from McGill University, where we look at uncertainty on the X and controllability on the Y, we see that scenario planning is well suited for those situations in which uncertainty is high and controllability is low. I'd argue exactly the issues that we're having with non-native species. So a scenario is typically some kind of plausible outcome or plausible story that we use to help describe highly complicated or uncertain issues into these kind of neat storylines. Many of you have heard of probably scenario frameworks in the past. They began in the Second World War as a type of war game analysis, scenario planning. Later, they became a part of business. This is Shell. They emerged from the 1970s oil crisis by using scenario-based planning for their company structure. They've been used for the transition to democracy in South Africa, community planning in Europe, and more recently, the scenarios have been used for environmental assessments, including the Millennium Ecosystem Assessment that we're all well aware of. So today I want to talk about a scenario-based approach about summarizing a future, if you will, a future in which invasive species are playing an increasing role, and as a mechanism or tool to which we can try to communicate to the public what type of future they might want to like to have, and then what they can do to actually promote or prevent themselves from going into that direction. So these scenarios are kind of connect the possible changes and pathways in the future to a future and how these non-native species will actually interact with human perception in terms of how they view a future that they might want to live in. So scenario planning includes a number of different things, and the story of the 21st century might follow many different pathways, depending on how we individually respond to non-native species or collectively, and whether we act in a more proactive way or a reactive way. So scenario planning typically involves a large number of individuals sat in a room with a lot of expert knowledge to come up with these different, usually 3 to 4 scenarios, something that the public can grab onto, again, to translate more complicated science. These scenarios I'm going to present you today includes one person's one person's ideas, mine, usually involving me being in a pub or a bar after multiple beers. So I take no laughing, come on guys. I took full responsibility of what you see here, but this is not a ecosystem assessment approach. This is me and my viewpoint on invasive species as we move forward. So these scenarios are designed to be a narrative linking the historical past to the new future involving invasive species. And what I've shown here are 4 different scenarios in which I will go over, highlighting again where we are in these different regions. Let's start right here with New World Order, in which it's a collective reaction, but in a reactive way. The New World Order might be governed by forces that have dominated globalization to date. This is where we have open borders, a lot of trade, economies which are linked throughout the world. And this trade creates new opportunities for intended and unintended movement of invasive species. One might argue that over time, and as faunas become more homogenized, this distinction between native and non-native might be less and less useful, again, in an extreme case. So we know that when we look at local species pools, they're shaped by a series of filters, which are historical zoogeographic filters. We're keenly aware that we have intercontinental transport through trade, such as global shipping shown here, or intentional fish introduction shown here in these 2 schematics. We also know that continental and basin barriers are getting broken through recreational boating or intentional fish introductions, where in the United States it started on horseback with milk cartons, and now we helicopter trout into alpine lakes. So we know that all of these barriers are basically getting broken down. So I would like to be not the first, but one of many to introduce the new Pangea to you. I think George Orwell had it right. Some species are more equal than others. And in fact, we're seeing a kind of a global homogenization of faunas because of this openness of trade or a new world order. Evidence for homogenization has occurred at multiple spatial scales, and we've seen in previous talks on this earlier. Here are just some continental scale analyses. In all cases, the more red, the more homogenized. I live right here in Washington State. But today I want to talk a little bit about a global perspective on this and give a little glimpse into this new world order. And it's going to ask the simple question using some data that I've collected: are species invasions dissolving these barriers and causing everything to look alike? So I've collated a global data set for species occurrences for about 1,400 freshwater fish occurring in 225 countries. This has been a long, painful process over time, but I did it at the country level because that is where you can get the most accurate records for species occurrence. I quantified faunal similarity both historically, that's native species only, and present day where you have native and non-native together. And I looked at a real simple index of similarity, beta sim. This focuses on changes in taxonomic composition over time. And then quite simply just looked at the change delta between contemporary, that's present day community similarity, pairwise between all the countries, and historic. Okay? First, I just want to illustrate that in fact it is a small world after all. We see about 422 fish species have a known and has been known to have established outside of their range. And the top 25, some of which are shown here, account for about 50% of all introductions. So it's not too surprising, these list of players that we see here. They've been really the ones, the cosmopolitan species that have been moved around a lot. One example, which I just want to highlight here, is rainbow trout. Rainbow trout is a great example that we illustrated earlier. Native to the Pacific Northwest region, and the rim of North America. It's now been introduced to almost 100 different countries globally, shown in red. So these talks, and I'm definitely not a fan of rainbow trout, but you can thank me for rainbow trout occurring in my home state. And in fact, the strain of rainbow trout that has been introduced globally, the Donaldson strain, was a professor in my university who actually generated the dominant rainbow trout, which has been now used globally. Genetic studies shows that you see genes of this species all the way down here in South America. You can thank me later with a beer. This is the result of this analysis. This is a map of the world, clearly. This is a change in similarity. Everything non-yellow means that it has increase in similarity with other countries over time. So you can see that quite strikingly, the world has become homogenized. There's been a 5% increase in mean fish similarity over time. So historically, the average pairwise similarity between countries was 10%. It's now 15%. We see the big players like the United States, South Africa, much of Asia, which has shown the greatest levels of homogenization because of that introduction of non-native species. So it's quite striking when you see something like this. On average, countries now share an additional 4 species. And just I wanted to show a couple great examples here. Countries who historically shared no species in common, and rightly so, now share, for example, the US and Singapore, 33 species. Australia and Germany, rightly so, they shouldn't share any species, now share 13. The UK and Argentina, 15. Sweden and Zimbabwe, very similar environmentally, now share a whopping 8 species. So homogenization is the rule, not the exception. And just real quick, I want to illustrate that the concerns that scientists have about homogenization is echoed in the cultural homogenization that we've seen around the world and has been well aware of. So if it's welcome to homogenizationville, a place just like everywhere else. James Kunzer had a great quote: if every place is the same, why go anywhere? In fact, we're seeing this homogenization. Regional dialects are going extinct, whereas the English language is being taught mandatory in many places of the world, so we linguistic homogenization. We see McDonald's popping up in Russia with house sparrows and pigeons. I think that says it all. Okay, now I want to illustrate the fortress twirl. This is right down here where countries are acting or regions are acting individually, but in a reactive way. In this case, it's the opposite. Rather than increasing trade, they're looking inwardly towards themselves. So they're intervening, they're having a strong control on which species come in versus not. This is typically through regulatory practices. And we have an overly protective government, which gets in the way of free markets. And we're seeing this currently in some places. We're seeing stricter limitations on international trade. throughout the world. New and updated federal regulations on foreign species, as well as advancing this kind of paradigm of guilty until proven innocent. So we're seeing more blacklists, more red lists, et cetera, et cetera. So this is really a logical consequence of really, I would argue, scientists' inability to predict species invasions and then to translate that information into the political arena. So where have we failed? These are just three places where I think that we have failed as ecologists. First, we've had a very naive perspective on non-native species. Again, non-native species have always been viewed as negative, whereas we've not fully recognized the conservation value of these species. I won't be talking about that today, but I will be talking about how we are chasing the invader ambulance and how we've had really limited translation of science into management. And no means are these novel or anything like that, but I just want to illustrate these as two things that are on the forefront of my mind. One, I think we're all keenly aware that our knowledge of invasive species are really focused in on a very small number of species. And these are usually the ones that have already been illustrated to have ecological damage. That's the funding that we can get. And when we look across literature, we see a lot of studies, which I call Me Too studies. That is, they're repeating literature, repeating studies that have been done elsewhere with the same organism, but just in a different environment. Now, I'm not saying that these studies aren't important. The context of where you want to apply the science is very important. But I'd argue that there's a plethora of other species out there that haven't been examined for potential impacts, and that we need to stop doing these Me Too studies and really promoting these more exploratory analyses into other suites of species and to other geographies, which we just haven't spent the time. Second, we've really had limited translation of science into management practices. This is a figure I've taken from a recent bioscience paper. On the x-axis is really time and effort, and on the y-axis is the completeness of the activity. And as scientists, both young and old, we've traditionally focused in on this block right here. We get some funding, we collect some data, we analyze it, we publish it, we feel pretty good about ourselves, right? And then we move forward. Now, I speak to an audience which has a lot of science that has on-the-ground management. So I really want to applaud all of you for taking these next steps, but I think we need to further promote that. And that is these extra tasks in which we go from the transfer of knowledge to implementation to actually testing the efficiency. This is where effort needs to be spent, whereas unfortunately, I think there's some literature out there in which we're spending maybe more time and effort in refining, say, predictive models, ecological niche models, to better predict species invasions, and we're increasing our predictability by 1 or 2%, where the reality is our effort should be better spent in actually translating that science to on-the-ground management, where we can have proactive prevention of those vulnerable ecosystems, et cetera, et cetera. And quickly, I just want to highlight the fact that we need to look for these opportunities to inform policy and really kind of drive through these policy windows when they actually are open. And what I mean by that is that if we look over time, we're looking for these instances in which the problems have been highlighted, there's policy alternatives, and the politics are right, if you will, to actually make those decisions. And often we are identifying problems all along, but they're not matching up to the time when policy is actually in place to make those decisions. So I think we just need to continue to be vigilant about keeping the problem or the challenges, I'd rather say, of invasive species on the forefront of policy, so that when these windows open up, we'll have the opportunity to actually interject science into change. Third, I want to illustrate the engineered world. This is where we are proactive and acting collectively. This represents, again, a globally connected world where we're managing it heavily, and we're often engineering ecosystems to deliver particular goods and services. This is where technology and market-based incentives are used to achieve solutions to environmental problems. And increasingly, we're seeing more and more of these proactive management strategies. These include things like taxon resubstitution, in which we're recognizing that non-native species can actually have the same function of lost native species, so that we use non-native species in a way to actually promote conservation or to achieve certain ecosystem services. There's the wonderful discussion over assisted colonization or managed relocation, however you want to package that more prettily. And then there's restoration through community reassembly. I just want to spend a moment talking about assisted colonization. Many of you have probably increasingly read about this in the literature. It's the idea of dropping off polar bears in the middle of the desert. No, I'm kidding. But it is the point of basically moving species from one area to another so that they can stay within their climatic envelope. The fact that climate change is so rapid that naturally organisms cannot disperse to keep within their climate envelope, therefore we have to move them. A real healthy debate has evolved over the costs and benefits of this, and these are some of those headlines. As a strategy for mitigating against the effects of climate change. There's been a lot of back and forth over it. And the fact is that although scientists are quick to kind of throw out this idea, the idea of moving a species into a new range sounds a lot like moving an invasive species or a potential invasive species. The fact is that this is already occurring. Conservation groups are moving plants around from Florida north into North Carolina. They're moving, fishermen move fish around. We need to engage in this conversation rather than separate ourselves from it at the onset and just say that it's not a good idea. So I just wanted to highlight a table here, which is just a simple table that illustrates these are a series of life history characteristics of freshwater animals that are typically associated with likelihood to go extinct, so extinction-prone traits, whereas likely to be invasive. There's a large amount of literature on this. And this is an example of, in a lot of these cases, the traits actually differ between the two. So that is the candidates that we might want to move for assisted migration and the traits that they have are likely to be very different than the traits that predispose a species to be invasive. So maybe there is actually a lower risk than we think it is of moving a species from one area to another. But I can't really talk a lot about the pros and cons of this. Highly controversial. I'd love to talk more about it. But we recently published a paper in Conservation Biology talking about how freshwater systems are likely to be the first place we'll look to for assisted colonization because of the dendritic nature of river systems, the east-west traveling of rivers, where you need to go north to stay within your climate envelope. But they're also likely to pose the greatest harm if we move species from highly isolated areas into another area. So there's no answer there, but it's going to be a challenge. And finally, I just want to illustrate that this engineering of future ecosystems is occurring currently. And it's going to evolve. A lot of this restoration might involve the deliberate engineering of ecosystems, of how we like to see them, or the types of ecosystem functions in which they're going to provide. So this forward-looking restoration, this is an article for US nurseries saying, are we going to have the plants available to actually then make this forward-looking restoration happen, where we're intentionally moving organisms into certain areas. So the reality is that it's here, the conversation is here. And as scientists, we need to be ready to answer the critics or to actually support some of these actions. And finally, I want to end up in this lower right-hand corner, which I call the management mosaic. We're talking about, again, acting individually, but in a proactive manner. And in this management mosaic, I envision this kind of asynchronous regulations of policies at federal, state, or provincial, or local levels, which may compromise the effectiveness of invasive species or management responses to invasive species. So right now, the activities of resource managers and the general public really impact their neighbors' actions. That is, the actions which I do here to try to stop invasive species or eradicate it is going to be influenced by neighbors around us. And if you have a mosaic of different actions or different policies, you're likely to have a weak link problem where reintroductions or re-invasions is likely to occur. Here's an example from the US. These are the states in the US. And this shows the states which have management plans or comprehensive aquatic plans. And you can see this as a patchwork, that you can see that some states have management plans, whereas their neighboring state doesn't. Invasive species do not respect state borders. So we have this real problem with this kind of mosaic of policy and management actions which need to be reconciled so that we can eliminate these weak links when talking about more holistically managing invasive species. There's also what I just want to illustrate is the management sandbox. Again, this just illustrates the fact that this mosaic is going on, and for this reason, there's really not much incentive to control an invasive species if it's likely to get reestablished from a neighboring area that's not working on it. So here's a great example. Throughout the US, we're spending millions of dollars of eradicating Eurasian milfoil from lakes. Milfoil it chokes out habitat, kills fish, entangles swimmers and makes them drown, decreases property value, and we're spending millions of dollars to remove them, but then it only takes one introduction event from a neighboring lake, which is not doing those eradication efforts, for it to become reestablished. Another example is that we're road-owning alpine lakes to remove predators, and then bait bucket biologists, that is fishermen who move fish around, then just reintroduce them the next season. So there's this real mosaic and a real challenge in terms of the public perception of the actions that we're doing. And just to finish off this political jungle gym, I like to illustrate again as an example of this mosaic, that in my opinion, in many areas, policy for invasive species is nothing short of paradoxical. This is the Washington Department of Fish and Wildlife. So we're in the Pacific Northwest. It's cold. It's salmon habitat, right? Salmon, salmon, salmon. And we have a warm water fish program that intentionally stocks bass and sunfish and other warm water fish for recreational opportunities. This is the goals of the program. They want to improve warm water fish while having minimal adverse effects upon the cold water fish populations. I don't quite know how they can plan to accomplish that, but here it is. You have a state organization where on one hallway you have promoting sport fish that eat salmon, and then in the other hallway you have all these salmonid biologists trying to eliminate non-native species to save endangered salmonids. So a great example is smallmouth bass shown here. Up to 90% of their diet can be salmon. They can eat up 40% of an annual run coming out of the tributaries of the Columbia River. But then we have big groups like the Washington State Bass Federation that spends millions of dollars to promote this fishery. And tough decisions need to be made here. The decisions aren't us, it's basically the public and their perception, in this case, of the pros of having this species versus the con, and we need to inform that debate. So just to quickly finish up, the simple point is that trend is not our destiny. If we think about currently we're here, and if we think about where is society likely to go with respect to these different scenarios, and the point is if we look 50 years into the future, are we going to be in a new world order? Are we going to be engineering our ecosystems to exactly how we want to see them? And where we are in here is really dependent upon how we shape the debate of the perception of non-native species. So to finish, I want to just to illustrate the fact that scientists are really challenged to reconcile the historical biogeography of these native species with this emerging and rapidly expanding spread of invasives. I think we can really benefit by looking to the Roman god Janus, who was basically the god of doorways. So he had two heads. He looked both forward and back. He was the god of beginnings and endings. The month of January is named after him. Janitors, which clean the hallways and guard doors, are the namesakes of this god. To me, Janus reminds me that we need to be aware of both where we've been in terms of looking past mistakes and management errors that we made for invasive species, as well as being reflective and looking to the future while we try to plan the types of landscapes and ecosystems that we value and that we want to see into the future. So I think in this meeting we've done a lot of good backward reflection and forward looking. I think it's on us to take this approach to decide where invasive species fall into the conservation debate, where we might require a new discourse on talking about non-native versus invasive species, and how we can do science to actually meet the management and policy challenges ahead. And with that, I'd like to thank you all for your attention.